Again our course name we should show that this is the dairy and food products process, food process and products technology, right, dairy and food process and products technology. So, in the previous class I was referring to, if you remember, that refrigerated storage, though we gave the definition any temperature between 0 to minus 23, and after that I said that if why it is in most of the books it is written that refrigerated storage or cold storage or frozen storage is normally at or below minus 18 degree centigrade. Then I raised this question, why minus 18? Because minus 18 is a odd number. It could have been 15, it could have been 20 or 25, something like that. So, why typically minus 18, right? This was the question which I raised, and obviously, if you look into the history, you will find that this SI is recent times, right. It is recent times, maybe couple of decades back SI has come up, but before that many other units nomenclatures were there, and one of them was FPS, right, and perhaps one of the oldest unit system. So, in that FPS, Fahrenheit is the unit for the temperature, right. So, things were all measured in Fahrenheit, and the improvement of the society or world has taken up more or less, say, right from the First World War onwards, very rapidly, right. And before that, yeah, things were not so much, and for movement from one place to other for business or any other purpose, people had to travel long, and that travelling normally either with some animal like camel or horse or things like that, donkey, whatever, right. So, a lot of time used to be spent on this travel, and since like today you have so many eateries here and there, things were not there. So, people used to also take a lot of food material along with them, and again science has come up like that from the use. People who were taking these, and they have experienced that if they had travelled through the areas where the temperatures were in that time in Fahrenheit 0, then they were very good. There was no problem after consuming. But if it was not so, then things were rotten or gone wrong or infected, blah blah blah, right. So, people came to know, science took from this that yes, 0 Fahrenheit is one temperature where the material food is maintaining its ability for a long time. It is not getting rotten, it is not getting poisoned or any other. So, 0 Fahrenheit was considered to be the temperature at which food material can be stored for a longer period. This is by experience. Science has developed from there. And this 0 Fahrenheit, if you convert it into centigrade, you will see that it is coming somewhere 17 point something, some decimal. As I said somewhere that kilocalorie 9, 4, it is easy to remember, like just like this 0 Fahrenheit, how much centigrade is just not possible to say unless you memorize. I did not. It is 17 point something, right. So, to make it whole number, this 18 came up, that 17 point something is not easy to remember. So, let us make it 18. So, that is why this 0 Fahrenheit got converted into centigrade as 0 Fahrenheit equivalent to 18 degree centigrade to be the temperature where food materials can be kept for a longer period of time, right. That is how minus 18 that came up, 0 Fahrenheit equivalent to minus 17 point something degree centigrade is roughly equal to minus 18 whole number minus 18 degrees centigrade, right. So, minus 18 or below, because sometime will come afterwards, there is a term called Q10 or temperature quotient, right, temperature quotient. Okay. Let me use it now, since it has come. Let me use it, and let me also try to use this system. I can write here, this is pen. So, Q10 is said to be K T plus 10 degree over K T, right. So, this K T plus 10 degree over K T is referred as Q10, or this is termed as temperature quotient. Right, QUOTIENT, temperature quotient. This temperature quotient is defined as the rate of reaction at any temperature T, this T can be any, to that at T plus 10 degrees centigrade, right. So, Q10 will be, say if it is 20 degree, if T is plus 20 degree, then if we make this plus 20 degree, so K 30 over K 20, this roughly can be said to be equals to 2, right. So, any rate of reaction, any reaction, be it chemical, be it microbial, be it chemical, microbial, biochemical or enzymatic, any kind of reaction will follow this simple temperature quotient law, that a temperature at a reaction at a temperature say 20 degree, if the temperature is raised by 10 degree, so that is 30 degree, then the rates of reaction which were at 20 degree will now become double at 30 degree than that at 20 degree, right. Similarly, if we increase from 30 degree by 10 degree to 40 degree, then the rates of reaction is doubled from that at 30 degree, or rather it is doubled at 40 degree than that at 30 degree. So, likewise, if we go on increasing, so each 10 degree is making double of the rates of reaction than that at the previous 10 degree, right. So, this is rates of reactions are increasing, right. All rates of reactions, again be it chemical, be it be it biochemical, be it enzymatic, be it microbial, any kind of reactions that will follow this, if it is for increase of temperature. Now, if we do the reverse, right. So, from 20 degree to 30 degree it was double roughly, right. I am not saying that chemical also will give 2, biochemical also will give 2, enzymatic also will give 2, or microbial also will give 2. There is no such equation that it will be 2, but their numbers are very close to 2. So, roughly, that is why I have given this symbol roughly. So, roughly it can be said to be doubled, right, for understanding. And if the reverse is done, that is, if the temperatures are lowered by 10 degree, so from 30 degree whatever it was, at 20 degree it will become half of that, that is inverse of 2, that is half, right. From 20 degree, if it is lowered by 10 degree to 10, then whatever rates of reactions were at 20, now it will become half of that at 10, right. So, this way if we go on decreasing from 10 to 0, 0 to minus 10, minus 10 to minus 20, like that, as we are decreasing, then the rates of reactions are also decreasing. That is why minus 18 we said 0 Fahrenheit equivalent to minus 18, that is the temperature where we assume that the rates of reactions will be minimum and there will be no microbial decay, microbial growth, microbial spoilage or enzymatic spoilage. At the most, they will be under dormant stage, right. This is the philosophy on which the cooling is entirely dependent on, right. Cooling storage or long term storage under refrigeration, under freezing, under frozen condition is fundamentally because of this, that if you are lowering the temperature by 10 degree, the rates of reaction is becoming half. So, each 10 degree lowering will make the temperature half of that. I will make the reactions half of that. So, that could be chemical, biochemical. Biochemical, I gave the example that you have taken fat and that fat is converted into glucose by the body. So, that was possible only by some biochemical reactions. One of the good book, which book I have not given, the names afterwards perhaps I will give, that one of the very good book on biochemical, not part of this course, is Leninger, Leninger, on biochemistry. You will see lots of cycles are there, right. From here it started one product, then another, then another, then another, then another, then another, then another, like that a cycle is being formed, right. For example, one such cycle is called TCA cycle. Our respiration is also under that similar cycle, that is also under a cycle, right. It comes from that glucose and makes carbon dioxide, water and energy, and that is under refrigeration cycle. You will get it in Leninger. This is not under this purview of this class, but as a reference I am telling that you go to that book and see lot many things and you will understand biochemical, right. So, these reactions are minimized as the temperature is lowered from any temperature to 10 degree less than that temperature. So, depending on what the product, obviously a product whose cost is 50 paise, say, or 1 rupee a kg, you will, and though if you bring it to minus 20, it may stay for 12 months, say, for the sake of saying, if we assume. Obviously, you will not keep, because for making it minus 20, you have to spend money. Why should unnecessarily one product whose availability, if it is high, or price is so low, that is 1 rupee per kg, that means it is plenty available, that is why it is 1 kg, 1 rupee. Had it been not available so much, then its price would have gone up. So, which one you will keep at which temperature, many factors will come forward. It is not a single parameter by which you will judge, you will decide, I will do this, based on many things, and maybe something is consumed so much that within couple of months this is consumed. You do not need to unnecessarily extend it for years together. So, why unnecessarily additional effort you will make, additional cost you will incur, so that the price becomes high and the requirements are low. So, depending on that market demand, supply, everything, you will decide what to do, when to do, how to do, right. So, this Q10, remember, this is one very good example or information to keep in mind in terms of any processing and preservation, right. So, we come back. So, that we tried, and now again coming back to that. Okay. So, we can now say that we can divide in terms this Q10 is one such, right. And we earlier also said that if you remove the moisture, then in the definition of so many perishable, non-perishable, naturally perishable, those definitions we have said that if you are removing moisture to the level where the organisms cannot grow, so that level will allow you to keep the food material for a longer period, right. So, in this term another scientific term will come up, that is called water activity. Normally, the moisture level in the food, we call that in terms of water activity. By simple definition, it is defined as the ratio of two pressures, one vapor pressure of moisture in the food material at a temperature, because pressure is a function of temperature. So, at a given temperature, the vapor pressure of moisture in the food material to that vapor pressure of pure water at that temperature. That is a simple definition of water activity. So, in terms of understanding, then we can say that availability of water, right. Water activity, in other words, say the availability of moisture for the organisms to grow or multiply or act, right. So, water activity, in terms of that, when we refer to drying. So, there again, since it is coming up, let me also say here, as I said, no, there it cannot be within a frame wall of this, that whole course has to be like that, because so many ancillary things do come up, which as teacher we think that if it is also shared with you, then that may help you in understanding, right. So, like that water activity came up, and the moment water activity came up, then also I should also say that there are microorganisms, there are basically we can divide, there are n numbers, n varieties, everything, but we can divide for food, we can divide them in three parts. One is bacteria, another is mold, and third one is yeast. So, bacteria, yeast, mold, these are the three categories of organisms, right. In terms of water activity, bacterial growth, action, everything is around 0.9 or above in terms of water activity. I define water activity again, it is the ratio of vapor pressure of moisture in the food material at a temperature T to that the vapor pressure of pure water at that temperature T, right. So, if that water activity is 0.9 or above, then bacteria can survive, grow and multiply and do all its action. If it is less than 0.9, then bacteria goes out, it cannot do any activities, it cannot survive. Then comes yeast. Roughly again, as I said, there is that Q10 2 I gave example, that is the representative number. So, this 0.9 is also a representative, does not mean all bacteria will be like that. There could be some difference, right, but by and large, so that is how we generalize. So, 0.9 will be bacteria. If it is less than that, say 0.8 water activity, then why it is becoming then fraction? Because the pure water has higher vapor pressure than that in the food, because food it is not only moisture, along with that some other things are there. So, it is lowering down the vapor pressure. So, vapor pressure at a given temperature of the pure of the moisture in food material to that vapor pressure of pure water at that temperature is the water activity. So, 0.8 is the water activity where yeast can grow 0.8 and above, yeast can grow and multiply and do good thing, bad thing, whatever activities, right. Bacteria also, it is not that all bacteria are enemy, they can be good, they can be bad, depending on where, how you are using, where, how they are acting. So, 0.8 above yeast, 0.9 above bacteria, 0.7 above mold, right. So, if we bring down the water activity below 0.6, then problem with moisture is out. So, in all dried material, this water activity level comes down. In many cases, it comes down much more, but this is one factor which plays into, right. So, if we look at this tree where how we can keep food material, if we look into that, you see we are saying that food, if it is in presence of air, then all three types of organisms, that is aerobic, bacteria, yeast or mold, all three can grow in presence of air. So, under that, at high moisture level, it is aerobic bacteria, yeast and mold, all three needs moisture, high moisture level they can grow. If it is a low moisture level, then bacteria, yeast cannot grow, only mold can grow, right? Only mold can grow. But if it is like that, in absence of air, then anaerobic bacteria, not aerobic bacteria, anaerobic bacteria can grow. Along with that, yeast also can grow. Mold cannot grow, because mold needs air as well moisture. If moisture is also less, still mold can grow, but air is a must. So, it is aerobic. But anaerobic organisms, anaerobic bacteria is also there, yeast is also there. So, they can grow at this low in absence of air. So, anaerobic bacteria and yeast can grow. Again it comes, if it is high moisture, then both of them, anaerobic and yeast, can grow and multiply and do action. But if it is in low moisture, then none of them, because we have seen here low moisture only mold can grow in aerobic, here also in anaerobic none of them, yeast, mold, bacteria, none of them can grow. So, ideal condition is that we should get ideal condition is that we should get low moisture, and in absence of air we should be able to preserve it for long period. But it is ideal situation. Maybe many food materials do not come under this purview. So, that is why this ideal situation may or may not be suitable for all the food materials. But ideally we can tell that this is the situation where all the food materials can stay for a very, very long period, right. So, I told you the other day that I will give you the reference. So, these are the some of the, like the Technology of Food Preservation by N.W. Desrosiers and J.N. Desrosiers, Elements of Food Technology by N.W. Desrosiers, Food Processing and Preservation by Shiva Shankar, this is Indian. Then Food Processing, Biotechnology Application by S.S. Marwa and J.K. Arora, Foods, Facts and Principles by N.S. Mani and M. Shadashami, and Milk and Milk Products by C.H. Eccles, W.B. Combs and H. Mackey, Outlines of Dairy Technology by Sukumar De and another Indian writer, Spices and Seasonings, a Food Technology Handbook by D.R. Tenter and A.G. Grenis, and what I normally follow and like very much, that is Principles of Food Science by Marcus Carrel, Owen R. Fenema and B. D. Lund. This book is known as the book in the name of Fenema. Fenema, only if you go and tell that librarian or somebody will bring that typical book only, this book only. So, it is known by Fenema and it is a very good, well written. Nowadays, the books which are available, most of them are either it is taken from one or other, or maybe most of the cases that it is edited books, right. So, lot of writers are contributed book. They are not on the basic principles, but these books are on the basic principles. Fenema is one of the best, right. Thank you.